Okay, section 3.2. We have just found numbers that describe the middle. Now we want to find numbers that describe the spread, the variability, okay? An average distance from the mean, okay? Something, how the data values are spread out. So this first example, a random sample of seven northern pike from Tolleson Lake gave the following lengths rounded to the nearest inch. So we have these 7 lengths, so we know n is 7. And the first example asks us to find the range. Well, the range is very simple. It's simply the largest data value minus the smallest data value. So 46 minus 21 gives us a range of 25 inches. Now that's fine. That tells us, the difference between the largest and the smallest data value, but it doesn't give us any information about what's happening in between. So what we really want to find is an average distance from the mean, okay? So the first thing we're going to do is we're going to find our mean. We don't actually need the mean to calculate our standard deviation, but we're going to have it so we can talk about it. So when I added up my data values, found my sum of my x's, I did the 21 plus the 27 plus the 46 plus the 35 plus 41 plus 36 plus 25, and I got 231. Okay, so to get my sample mean, my x bar, I take 231 and divide it by 7, and I get 33 inches. Okay, that looks like a pretty good middle. All right, so 33 inches is our middle, our sample mean. Okay. Now, we want to find the average distance from the mean. Now, we have to start, we want the standard deviation, but we have to start by finding the sample variance. Now, to get the variance, we need another summation. Okay, this first summation that we need is the sum of the squared data values. So now I took 21 squared plus 27 squared plus 46 squared plus 35 squared plus 41 squared plus 36 squared plus 25 squared to give me the 8,113. Okay. Now the formula for variance, it's s squared, and we have the sum of the squared x's minus the sum of the x's. Okay, that's what we found up here, this 231 squared over n divided by n minus 1. Okay, so the sum of the squared x's, that's that 8,113. The sum of the x's was 231 squared divided by 7 minus 1. Okay. Now, when I work this out in my calculator, I'm going to show you how I do this, because if you round, here, and then you subtract, you divide, you round again, you're not going to end up with the right answer. So I work this out without doing any rounding until my final answer. So I'm going to take my 8,000, I'm going to do parentheses, 8,113 minus 231 squared divided by 7, close my parentheses, okay, and then divided by 6. And when I do that, I get 81.6 repeating. So we get an 81.67, and these are inches squared. Okay, your variance is always in squared units. Now, this is not our average distance from the mean. Okay, we have to undo all of that squaring. So to get our sample standard deviation, okay, our average distance from the mean, we find S, our sample standard deviation, which is just the square root of our variance. So when I work that out, I get 9.04 inches. So our sample mean was 33 inches, and our data values have an average distance from that of about 9 inches. All right. Let's look at this next example. A random sample of 330 adults asked the maximum amount they would spend on a ticket to a top-rated performance and gave the following results, where X is the cost and F is the number of people who would spend that amount. So there's 62 people that said they'd spend $20. There's 83 people who said they'd spend $30. 120 people said they'd spend $40. 40 people said they'd spend $50. And 25 people said they'd spend $60. Now we know there's 330 adults, but if they hadn't told us that, we would have to add up these frequencies to get that 330. And that's what I'm showing you right here, okay? Now, the sample mean, we need to add up the x's. So let's think about this. How many 20s are there? Well, there's 62 of them. You know, and we could write, I guess, 20 plus 20 plus 20 plus 20 plus 20 and so on until we have 62 of them listed. But it's much quicker just to say there were 62 20s, so 62 times 20. Plus, and how many 30s are there? Well, there's 83 of them, so I did 83 times 30. Plus, how many $40 were there? There was 120 of them, so I did 120 times 40. Plus, and then there are $50, so 40 times 50. And then how many $60? Well, 25, so 25 times 60. So to get my summation of my x's, I just worked that out. 62 times 20 plus 83 times 30 plus 120 times 40 plus 40 times 50 plus 25 times 60 and got 12,030. So my sample mean is the 12,030 divided by the 330, and we get $36.45, okay? So that's our number describing the middle, okay? Now, we want to find the variation, okay? The average distance from the mean. So we're going to compute the sample variance, okay? Now this time we need, of course, we need the sum of the x's, but we also need the sum of the squared x's. So that means we want, you know, 20 squared plus 20 squared plus 20 squared plus 20 squared, and we want that 62 times, okay? So now I'm going to do 62 times 20 squared, okay? How many 30 squareds are there? Well, there was 83 of them, okay? So 83 times 30 squared plus 120 times 40 squared plus 40 times 50 squared plus 25 times 60 squared. So adding up all those squared values gives you 481,500. So for s squared, I take my sum of my squared values, that 481,500, minus the sum of my x's, which was the 12,030, squared, divided by 330, divided by 330 minus 1. So again, on my calculator, I'm going to take parentheses, 481,500, okay, minus 12,030 squared, divided by 330, close my parentheses, divided by 329. And when I do that, I get 130.552. So we get 130.55, and this is in squared dollars. Okay? Now this is not the number we want, okay? We want the average distance from the mean, which is the standard deviation, which is S, and we take the square root of the variance that we just found. So the square root of 130.55 gives us $11.43. So the mean was $36.45, and the data has an average distance from the mean of $11.43. I'm going to stop right here, and there will be a part 2 with the rest of the examples.